This is the first final exam review, so I'm going to walk through each one of these questions. Obviously, some of you didn't have to do all of them, but so you'll stop wherever you're supposed to. But for those that have to complete them all, I'm going to do each question with explanation. So in number 1, we have to get rid of the parenthesis sets. So we have 10z plus 25 minus 10z, and then a negative times a negative makes it positive 16. So at this point, I know that the 10z's are gone, so 25 plus 16 gives me an answer of 41. In the next one, we are solving for x. There is an equal sign here. That tells me I have to solve and get x by itself. So the first thing we're going to do is subtract 5 over 12. And when you do this on Desmos, you have to make sure that that's in parentheses, and then you're also going to keep this fraction in parentheses. So you're going to have 7/6 x is equal to negative 13 over 36. And then we're going to multiply by the reciprocal of 7 over 6 on both sides so that this side becomes a 1x because those cancel. So this is x. And over here we're multiplying by 6 over 7. And 6 goes into 36 6 times, so we end up with negative 13 divided by 42. That will not reduce, but you always want to check that on Desmos. Number 3, we have to get rid of these parenthesis sets. So I have 20x plus 25 plus 30x plus 12 plus 5. And then on the other side, nothing can be combined, so 50x plus 43. Now we have to collect the like terms on the other side, so I have 50x, because 20x and 30x. And then if I take 25 plus 5, that's 30. And then if I add 12 more, I get 42. And from here, I'm looking at this, and if my goal is to solve for x, I want to get the x's on the same side. Well, when I subtract 50x on both sides, then my x's completely cancel out. So I have 42 is equal to 43, and that is a contradiction. So there is no solution to this one. There is no x I can put in that's going to make that a true statement. Number 4, we're looking at, again, solving for x because I know there's an equal sign. So the first thing I'm going to do is distribute here. So I have 2 over 15. And when you type 3/2 times 4/9 into Desmos, you're going to get 2/3 x. And then I get negative 15/2 here. So again, trying to solve for x, we have to add 15/2 to both sides. And again, I'll remind you that on Desmos, make sure you keep those fractions in parentheses. So my 2/3 x is still here. And then when I add those two fractions together, I get 229 over 30. And at this point, we have to get rid of 2/3. So again, we're going to multiply by the reciprocal so that the 3's cancel and the 2's cancel. So this side is just x equals. And over here, when I multiply by 3/2, I know that 3 goes into 30 10 times. So I have 229 over 20. And if we check that to reduce, we find it will not reduce. Number 5, we have an absolute value, so I'm solving for x again. And the first thing I'm going to do with this is to add the 6 to the other side. So I have 4x plus 4, and that's equal to the absolute value of 4x plus 4 is equal to 12. And because I have these two absolute value lines, that means I have two different equations. So I have 4x plus 4 is equal to 12, or I have 4x plus 4 is equal to negative 12. And you have to solve these separately. So we subtract 4 from both sides. So I have 4x is equal to 8, so x is equal to 2 is one of my solutions. On the other side, I get 4x is equal to negative 16, and x is equal to negative 4. So those would be my two solutions. Number 6 moves us into Module B, where we are talking about linear graphing. So for the slope, we have m equals y2 minus y1 over x2 minus x1. So we come up to our ordered pairs and we label one set x1, y1, we label the other set x2, y2, and we substitute. So we're going to have 2 minus a negative 3. And then we have 13 minus 11. So I end up with 5 in the numerator, and in the denominator we have a 2. So my slope would be 5/2. For number 7, we are told to put it into slope-intercept form, which is another way to say solve for y. So we add 3x to the right-hand side. I have 6y is equal to positive 3x minus 4. Make sure you put the term with x first. And then I divide every single term by the number 6. So that gives me y is equal to 3 divided by 6 is 1/2 x. And then negative 4 over 6 reduces to negative 2/3. So my slope is the number 1/2. Do not include the x. And then my y-intercept is b. So that's going to be negative 2/3. Next one says that we want to graph this equation. You can do this a multitude of ways. One way, and this one is in a good form to do this. If I have 3y is equal to 6, so I let x be 0, then I get that y is equal to 2. So x was 0, and y is now 2. So that goes up 2, and I put that point. Now if I do the exact opposite, and I let y be equal to 0, then we have 2x is equal to 6, and then x would be equal to 3. So 1, 2, 3, and I would connect those 2 points and have a straight line. The other way to do it would be to solve for y and use slope-intercept. If you choose to do it that way, I can walk you through that. Just let me know. Number 9, we are asked to tell the equation of a line that's parallel to this one. So what I need from this one is its slope. The slope is the number in front of x after you solve for y. So this one's already solved for you, so this slope is 3. So my second slope, which is the line I'm talking about, will have the exact same slope because they're parallel. So I have y minus, this is x1, y1. So I have y minus y1 is equal to the slope, and then parenthesis, x minus x1, which is the number 1. So I have y is equal to 3x minus 3, because I distribute my 3. Next one wants us to look at perpendicular. So it's very similar process to begin with. You find the slope of the line you're given. But this one does not have a slope that matches because it's not parallel. So I have m1 times the new slope I'm trying to find. Always, if they're perpendicular, has to be equal to negative 1. So if I plug this 5 in for that m1, I have 5 times the slope I'm trying to find is equal to negative 1. So I divide both sides by 5, and that's going to give me my new slope. So I have negative 1/5. So if I take negative 1/5 as my slope, this is x1, y1. Then we do y minus y1 is equal to my new slope, not negative 1/2, but negative 1/5. Sorry about that. Negative 1/5, and then x minus a negative 5. So now I solve for y, so I have y minus 2 is equal to negative 1/5. And then if I take negative 1/5 times 5, that's going to give me a negative 1. And then I add 2 to both sides to get my final answer, which is going to give me y is equal to negative 1/5 x plus 1. Number 11 wants us to factor, so we've now moved into Module D. So we have got to look at this and say, okay, I have 4 terms. So I'm looking at the GCF of these two, which is the variable y. So I divide here by y, I divide here by y, and I write it out front. So those y's cancel, so I'm left with x. Those y's also cancel, so I'm left with plus 6. This is a negative sign, so my GCF for these two has to also be negative. So if I look at these two, my GCF would be negative 2. So if I divide here by negative 2, I divide here by negative 2, and then, of course, I rewrite it in front of the parenthesis set. This is going to give me x plus 6. And this is the point where I'm looking for my twins, which are here and here. So I factor them out one time. And then if that's factored out, I'm left with y. And if that's factored out, I'm left with negative 2. And that is my factored form. For number 12, I have a squared minus b squared. And that's going to be equal to a plus b and a minus b. So what you do is take the square root of 144w squared, and that's going to give me 12w, so that's what my a is equal to. And then I take the square root of 49, and that's going to give me a b value of 7. So my factored form for this is going to be 12w plus 7, and the other is going to be 12w minus 7. All right, for number 13, we have a difference of perfect cubes. So this is the one where I have a cubed, and in this case it's a plus sign, b cubed. So these will factor into a and b, and then I have a squared, I do a times b, and then I have b squared. And this is where most of you learn SOAP. All right, so SOAP. So this first sign in between is the same as what you started with. The next one is always going to be opposite what you started with. And the last one is always positive. So to do this, I take the cube root of 27x cubed. So this is going to give me an a value of 3x. And then I take the cube root of 64y squared, y cubed, and that's going to give me a b value of 4y. So I plug this in. So my a is 3x, my b is 4y. The next one says a squared. So my a is 3x, and I have to square both of those. And then I have a negative. I'm going to multiply 3x times 4y. And then last but not least, we have the b value, which is 4y. I have to square those. So my final answer here is going to be 3x plus 4y. If I take 3x times 3x, that's going to give me 9x squared. Negative. All right, 4 times 3 is 12, and then I have an x and a y. And lastly, we have 4y times 4y will give me 16y squared. 14, we're still factoring. This is a trinomial, so this is where I'm looking at, they have to multiply to give me 1, which is out here and understood. We're not going to write that. 1 times 9 gives me 9, and I want it to add up to be a 10, so that's going to be 1 and 9. Since that front number is understood to be 1, I don't have to go through the long process. All right, this is x plus 1 and x plus 9. Now, in the next one, we do have a front number that is not 1. Your leading coefficient is 2. So this one takes a little bit more time. All right, we do 2 times 15 gives me 30, and then it has to add up to be negative 13. So in order to achieve that, you're going to have a negative 10 and a negative 3. So I do 2x squared, and then what I'm doing is substituting this with these two factors. So I have negative 10x minus 3x, and then you keep the last one plus 15. So GCF of the first two is 2x. Once I divide that, I'm left with x minus 5. This sign is negative, so the GCF is, and the GCF of 3x and 15 is negative 3. Once I divide by that, I get x minus 5. So again, I have my twins. I factor them out one time. If I factor that out of that term, I'm left with 2x. Factor it out of that one, I'm left with negative 3. Be sure if your leading coefficient is not a 1 that you do this longer process. 16 says we want to solve, so we are getting everything to one side. So I have 3x squared plus 23x plus 30, and that's equal to 0. So at this point, we are back to using 3 terms. So I have 3 times 30 is 90, and I need the factors of 90 that add up to give you 23. Don't forget to use 90 divided by x on Desmos. All right, 90 divided by x, and then create your table. You will end up finding that you have a 5 and an 18 that will work to do that. And when you do this, you are taking this middle term and you're replacing it with these two. So we have 3x squared plus 18x plus 5x plus 30. And then again, we are factoring 2 at a time. So GCF of the first two is 3x. I'm left with x plus 6. GCF of the last two, this is positive, so is this. So that's a 5, and I have x plus 6. And it's still equal to 0. So again, I'm looking for twins. I have x plus 6. If I factor that out of this term, I have 3x left. If I factor it out of this term, I have plus 5. and those are still equal to 0. So I set x plus 6 equal to 0, and I subtract, so I get x is equal to negative 6. And then I set 3x plus 5 equal to 0. And to solve this, we have 3x is equal to negative 5. So then lastly, we have that x is equal to negative 5/3. And those would be my two solutions. 17 says to simplify. So again, I'm factoring. So if I look at the top, the first thing I see is that it has a GCF of x. So that puts me down to x squared plus 7x plus 12. And then in the bottom, I also have a GCF of x, and I'm left with x plus 3. So at that point, I know that those x's are gone. They're twins and they're gone, so I'm just going to keep those and get rid of them so I don't have to worry with it. The next thing I need to deal with is I have a trinomial, so I have 12 is what they have to multiply to, and they have to add up to give me a 7. So this is going to give me 3 and 4. Since that front number is a 1, I don't have to go through the long process. I have x plus 3, x plus 4, and I'm dividing by x plus 3. So again, I have twins that are gone here and here, so my final answer is x plus 4. If you had it that it ended in the bottom, for example, you have to make sure to put the 1 in the numerator, so don't forget that. 18 says to divide. You can do this a multitude of ways. I am going to keep this one, flip this one, and change this to multiplication. So I have w to the 9th, z to the 6th, over 8w to the 4th. And now I'm going to multiply that by 5z squared divided by 12w squared z to the 4th. And then I'm going to multiply straight across. So I have 5w to the 9th, z to the 8th. And in the denominator, I have 96, w to the 6th, z to the 4th. So you're going to take the numeric part out front, your coefficient, and put it into Desmos to see if it'll reduce. This one will not. So then I'm looking at my variables, and I'm trying to figure out where do I have more. So there are more w's on top, so w will end there. I have 9 minus 6. And for my z's, again, I have 8 is more, and it's on the top, so I have 8 minus 4. So I have 5w to the 3rd, z to the 4th, and I'm dividing that by 96, and that would be my final answer. 19, I'm going to have to do a similar process because it is division of fractions. So I'm going to keep the first one just like it is. I'm going to flip the second one and change this to multiplication. So I have x squared minus 4 over x squared minus 6x plus 8. And now I'm going to multiply that by x squared minus 7x plus 12 divided by x squared plus 3x plus 2. Now, each one of those numerators and each one of those denominators is going to factor, so you have to factor it next. So x squared minus 4 is a difference of perfect squares. So x plus 2 times x minus 2, because that's the square root of each of those. In the other numerator, we have that they have to multiply to 12 and add to negative 7. So I need negative 3 and negative 4. Since that front number is a 1, I don't have to go through the longer process. This is x minus 3, and this is x minus 4. And I'm multiplying, so I'm putting them all together. For the bottom left, they have to multiply to 8, and they have to add to negative 6. That's going to be negative 4 and negative 2. And again, my leading coefficient is a 1, so I do not need to worry about doing the longer version. So I have x minus 4 and x plus 2. Minus 2. And then in this denominator, I need it to multiply to 2 and add to 3. So that's going to be 1 and 2, of course. And again, leading coefficient is a 1. So I have x plus 1 times x plus 2. And now all we're doing is looking for twins. So x minus 2's are gone. I have an x plus 2 here and here. I have an x minus 4 here and here. So my final answer is x minus 3 divided by x plus 1. Number 20, we're moving into section A2. So some of you didn't have to go this far. You finished at E from the last one. So if we are in A2, this is going to be a question that you'll be expected to do. So we're solving. We have a subtraction of 3x on both sides, and then we're going to subtract 5 from both sides. So when I do this, column by column, I get 8x is greater than 0. So you divide by 8, and you get that x is greater than 0. So I'll do it in two different colors on my number line. So I have to start at 0, and I know that in this case I have a parenthesis here, and I shade that way. Now to go do the other side, again solving, and we want x on the left, so I'm going to subtract, and then I'm going to add 8 to both sides. All right, so we have 5 minus 11 is negative 6x. I have greater than or equal to. The x's on the right side are gone, and I get 12. And then when I divide by a negative 6, I have to be very careful that I flip this sign. So I get that x is less than or equal to negative 2. So I got negative 1 there, negative 2 here. So I'm going to use a different color. And this one has a bracket here, and it goes off and shades in that direction. This is an OR statement, and because it's an OR statement, we expect these to split. When you write these down on the exam, you have to make sure that you write them in interval notation. So this one is going off into both infinities, so you have to be sure that you write this so that you don't get confused, and you're going to read from left to right. You have negative infinity up to and including negative 2, so that's a bracket. Because it's in two sections, you have to keep the union. And then I pick back up at 0, but I don't include it. So I use a parenthesis, and it goes on forever. So this would be the graph on the number line as well as the interval notation. You have to do both. 21, similar but just a little different. All right, I'm going to solve, and I want x on this side. So then I'm going to add 4 to get it to the other side. And in doing so, we get 8x is less than negative 8. I'm dividing by the number 8. So I get x is less than negative 1. So again, I'm going to do this in two colors. I have negative 1 here. And it's going to shade to the left. And it's a parenthesis because it's not included. Next one, I'm going to subtract 12x, and I'm going to add 21 to both sides. So I end up with negative 9x is less than positive 18, and I'm dividing by a negative 9. Again, when you divide by a negative, this has to flip. So you have x is greater than negative 2. So if that's negative 1, negative 2, of course, is going to be right beside it. And when I do this one, it is also a parenthesis because it's not included, and it goes off in this direction. So because this is an and, I am just looking for the overlap. So when I look at where I have both colors, it's only going to be right here between these two numbers. And both sides are parentheses because neither has inclusion. So I have the interval would be from negative 2 to negative 1. 22, we're moving into absolute value inequality equations. So the first thing you have to do is get the absolute value by itself. So I'm going to subtract 9, which gives me 15. And now I have to create two equations. Now most of you all write this in two separate, so this is less than 15, and this is less than, so this is an and. So I'm looking at the overlap. And then the other equation is 2x plus 3 is greater than negative 15. So I subtract 3 from both sides. This side gives me 2x is less than 12. If I divide by 2, I get x is less than 6. I'm going to go ahead and solve. I have negative 3, so I have 2x is greater than negative 18, so x is greater than negative 9. So I need a negative 9 here. 0 is somewhere in between, and then I have a positive 6 here. So again, using my two colors, I have this one is going in this direction, This one is going in this direction. And the only place that we have overlap is going to be inside here. And those are both parentheses. So the solution to this one is the interval from -9 to +6. 23 is the same thing, but the difference is that my inequality flows in the other direction. All right, so I get this by itself by subtracting 8 from both sides. This one is a greater than, so 22 minus 8 is going to give me 14. And because I have that greater than, this is an or statement, greater. So I have 2x minus 2 is greater than 14, or 2x minus 2 is less than -14. So I go to solve these. I'm going to add 2 here and here. So I have 2x is greater than 16. So divide by 2 and you get x is greater than +8. Over here, again, we're going to add 2 to both sides of the inequality. I have 2x is less than -12. And dividing by 2 is going to give me that x is less than -6. So on my number line, we have a +8 would be over here somewhere. 0 would be somewhere in between. And then I have a -6 here. Again, using two colors, this says that x is greater than 8, so it goes that way. And the other one says that x is less than -6. So this is an or statement, so we expect it to go off in different directions. Put your infinities on that number line, and then you read it from left to right. So you have negative infinity up to -6, but you use a parenthesis. Union, because there's another section. You pick back up at 8, and you go off to infinity. So you have to have, again, the number line and the interval notation. 24, we are going to solve this system of equations. You have the option to pick which one you want to get rid of. I'm going to choose x's because one's already negative and one's already positive. You're going to find the LCM of 3 and 5. That's going to give you the number 15. Now what that means is I need a -15 here and a +15 here. And they're not there, so I have to create it. So I'm going to multiply that entire line. So I need -3 to turn into -15. So I'm going to multiply that whole line across by 5. And in the bottom, I need a +15. So I'm going to multiply that entire line by 3. So I have -15x plus 20y is equal to 20. And I have +15x plus 9y is equal to 9. And when I go to my next step and add these, my x's have to cancel out, and ours do. So then I add 20y plus 9y gives me 29y. And 20 plus 9 is 29. If I divide both sides by 29, I get y is equal to 1. But that's not the final answer because I have to have an x and a y. These are ordered pair points if there is a solution, and it is unique. So I go back to one of my original two. So I have -3x plus 4y is equal to 4. And I'm going to plug this 1 in where that y is right there. So I have -3x plus 4 times 1 is equal to 4. So then I'm going to subtract 4 here and here. I have -3x is equal to 0. So x is equal to 0 after I divide by -3. So the solution is the ordered pair point x, y. Now we're moving into radicals. So this would be section, B2. So for this one, we are looking at 7. And this gives me 2 squared times 3. This is how the majority of you all are doing these. So the 7 is going to stay. This imaginary 2 out here goes into this exponent 2 one time. So that's 2 to the first. No remainders on that one. 3 has an exponent of 1, and 2 will not divide into that. So there's still a square root of 3. Lastly, you multiply this, and you get 14 square roots of 3. 26, we know that we need to make sure that we don't have a radical in the denominator. Because there are two terms, you have to multiply by the conjugate. So my conjugate for this is 7 minus the square root of 11. So I have to multiply top and bottom. In the top, I'm just going to distribute. I have 35 minus 5 square roots of 11. And in the bottom, I have to multiply. So I have 7 times 7 is 49. Then I have 7 times negative square root of 11. Then I have 7 times positive square root of 11. And then I have a positive times a negative is a negative. And this is the square root of 121. So I have 49. These cancel. And then this has a 11 squared, obviously. So this is going to be 49 minus 11. So this is going to be a 38 down here. If you can reduce it, you should. This one will not reduce, so that would be your final answer. 27, I'm told to combine this or simplify it. So 3 square roots of 3 is not going to change into anything else. Then we have negative 5. And if you go through and do your division on this one, you get 7 cubed. And then over here, you're going to end up with 5 squared times 3. So 3 square roots of 3 is going to have to stay like it is. Then I have negative 5. Now, this imaginary 2 out here goes into 3 one time. So that's 7 to the first. And then there's 1 remainder. So that remainder stays under. And then over here, I have the plus 2. That imaginary 2 goes into that exponent 2 one time, so that's 5 to the first with no remainders, and then I still have the square root of 3. So I have 3 square roots of 3, I have negative 35 square roots of 7, and 10 square roots of 3. Now, because these two match, I keep that, and then I combine 3 and positive 10. So 3 plus 10 gives me 13, and then I keep the square root of 3, and then the negative 35 square roots of 7 can do nothing else. So that question is now finished. 28 wants us to multiply. So again, I have to multiply this times both of those, and then I multiply the square root of 3 times both of those. So the square root of 10 times the square root of 10 is the square root of 10 squared, or 100. I'm going to write it this way because of the way you all like to simplify. So if I have the square root of 10 times 11 square roots of 3, the 11 cannot change, but the square root of 10 times the square root of 3 turns into the square root of 30. All right, then we have the square root of 3 times the square root of 10. So that's the square root, again, of 30. Coefficient out here is a 1. And then lastly, we have the square root of 3 times 11 square roots of 3. So the 11 doesn't change, and then I have 3 times 3, which is 3 squared. So this imaginary 2 goes into that exponent 2 once, so that's 10. Then I have these two, the 30s match, square root of 30s match, so I keep it, and I add the 11 and the 1, so that's a 12. And then lastly, we have the 11 is there, and then this imaginary 2 goes into that one once, so that's 10 times 3. 11 times 3. So I have 33 plus 10 is 43 plus 12 square roots of 30. You have to make sure that the square root of 30 won't get any smaller, and it will not. Next one is the same thing, but we're moving into complex numbers. So this is C2. And you have to remember the key thing with this is I squared is equal to negative 1. And if you have the square root of negative 1, that's what I is equal to. Those are your two takeaways from this one. So if I multiply this, I have 5 times negative 2 is negative 10. And then I multiply 5 times 10i, so that's 50i. Then I multiply negative 9 times a negative 2, so that's positive 18, and then there's an I. And lastly, we have these two. So I have a negative 9 times a positive 10 is negative 90, and then I have I squared. So this is going to come in quite a bit with these I squared, so you have to be careful. All right, this is negative 10. These two can go together because they are like terms, so this is 68i. And then over here, I have negative 90 times negative 1. Well, that gives me positive 90. So I have negative 10 plus 68i plus 90. So 90 minus 10 is 80 plus 68i. And that question is complete. Number 30, you have to not have any i's in the denominator because that's equivalent to having a radical in the denominator. So again, we have two terms down there. So I'm going to have to multiply by the conjugate, which is 1 minus I. So if I multiply across the top, I have I times 1, that's I. And then I have I times negative I, so that's negative I squared. In the denominator, I have 1 times 1 is 1. Then I have positive I, then I have negative I, and then I have negative I squared. So those are gone, and that become negative 1s. So I have negative 1 plus I, switching the order to always put the real part first. And then in the denominator, I have 1 minus a negative 1. So that turns into 1 plus 1, which is 2. And that's my final answer on that one. 31, it's telling us to simplify this. So I have a negative under here, and I also need to look at 162 and break it down into its prime factorization. So I have negative 3 minus. All right, first thing I'm going to do is take out that negative 1. And then I'm going to go off to the side, and I'm going to find my prime factorization of 162. So this is going to give me 3 to the 4th times 2. 81 times 2. So that gives me 3 to the 4th times 2. And then you're still dividing by 6. So I have negative 3 minus square root of negative 1 is I. And then I have this imaginary 2. That imaginary 2 is going to go into that exponent 4 twice with no remainders. And then I still have the square root of 2. So I'm still dividing by 6, and we're still simplifying. So I have negative 3 minus 9i times the square root of 2. And now I'm going to bust this apart and put 6 on each term. So negative 3/6 reduces to negative 1/2. Negative 9/6 turns into negative 3/2. And then I still have I square roots of 2. So since the denominators match, you can put it back together. You could have also, at this stage right here, you could have had negative 3 minus 9i square roots of 2. And if you're dividing that by 6, you can factor out a negative 3 on top. Actually, let's factor out a positive 3 on top. So that's going to give me negative 1 minus 3i square roots of 2. And then if I'm dividing that by 6, then 3 goes into 6 twice, and you end up with the exact same answer. 32, we are told to use the quadratic formula. The first thing I have to do is make sure that everything is on one side. So if I subtract 15 minus 9, I end up with 6, and that's equal to 0. So the quadratic formula is x is equal to negative b plus or minus square root b squared minus 4ac, and I'm dividing that by 2a. So this is my a, this is my b, and this is my c. So negative b would be negative 3 plus or minus, and then I take 3 and I square it, which is 9, and then I'm going to do negative 4, and then I'm going to go ahead and multiply a times c, so that gives me 24, and then I'm still dividing by 2 times a, so that would be 8. So we have that this is equal to negative 3 plus or minus square root 9 minus 96, and we're still dividing by 8. So 96, negative 96 plus 9 is our next calculation. So we are going to have the square root of negative 87, and we are dividing by 8. So again, we've got this negative under here. So this is negative 3 plus minus. I know it's an I, and then I'm over here looking at 87, and it's divisible by 3. So that goes in 29 times, and 29 is prime. So that does not have any simplification that we're going to have to do. So that stays, and then this is over 8. So that would be my answer for that one. Last but not least, we have the solving of radical equations. So the first thing we're going to do is move over the negative 1. So we add that to the other side. And at this point, we want to get rid of the radical. So to do that, I take the square of both sides. That gets rid of the radical, so I have 2x plus 10 over here. And on this side, I'm going to write this down twice and multiply it out. Don't try to do the shortcut because it's wrong. So you have 2x plus 10. This side gives me x squared plus 2x plus 1. And now we want to get everything to one side, so I subtract 2x and I subtract 10. So if I subtract 2x, the x's are gone, and 1 minus 10 is negative 9, and that's equal to 0. Well, this will factor into x plus 3 and x minus 3. So we think we have answers of x equals negative 3 and x equals positive 3. These are the questions, remember, that you have to check. So to check these, I plug them into the original equation up here, all the way at the beginning. So I have the square root of, if I put a negative 3 in there, I get 2 times negative 3, which is negative 6 plus 10 is 4, minus 1, and I'm seeing if that gives me a negative 3. Well, that's 2 minus 1, and that does not give me a negative 3. So that answer can't be in the solution. So if I check positive 3, I end up with the square root of 16, because 3 times 2 is 6, plus 10 is 16, and then I'm subtracting 1, and I want to see if that's going to give me the number 3. So this gives me 4 minus 1, which is 3, and that one is a true statement, so that is the only solution there should be. If you give me this one, then you have missed the majority of your points, so be careful with that.